Okay, welcome back to another video. In this, we're going to actually use the binomial theorem to expand a power on a binomial. So the one that we have that I'm going to be doing is 2 minus x to the 6th power. Okay, we're going to use the binomial theorem to help us be able to expand this out. Okay, now the binomial theorem, as it's stated, applies to x plus y, right, to the nth power. So in this problem, this is going to be like my x, 2 is going to be my x, and then negative x is going to be functioning as my y in this problem. Okay, so what do? The binomial theorem says that I do, well, I start with the 6th power goes on the top of my parenthesis thing, and I start at 0. Okay, so that's how Pascal's triangle starts, is at 0. And I do x to the 6th power. I start with all of, or sorry, my x, which is my first thing in here, which 2 is functioning as my x in this case. So I do 2 to the 6th power. I take my first thing and put all of the powers on that thing. Okay. Then I do plus, I increase this number by 1, right? And I do, well, I decrease the powers that are on that by 1, so I get 2 to the 5th, and then I increase the power on the second thing. So the second thing is negative x. So we raise that to the 1 power now. Okay. Plus 6, choose 2, times 2 to the, we decrease the power on that, 2 to the 4th, and increase the power on the others, on the other one. Okay. Keep doing the same thing. 6, choose 3, 2 to the 3rd, and then negative x to the 3rd. Oops, sorry, I can't tell if you can see that there. That's a 3. Okay. Plus 6, choose 4, okay, of 2 squared times x, negative x, sorry, that's our second thing, negative x to the 4th now. We increase the power there. Plus 6, choose 5, of 2 to the 1 power times negative x to the 5th power. Okay. Plus 6, choose 6 of just all of it on the negative x. Okay. Okay. So this is where, I don't know, I feel like Pascal's triangle is a little bit easier for powers of this. Binomial theorem is really effective if you just wanted to know like one term of this, right? If you wanted to just know how many, x cubes there are in this equation, well, you just have to look at where's the x cubed in here, and then you just compute 6 choose 3 times 2 cubed, and that would give you the number in front of the x cubed. Okay, but as it stands, there's all of this stuff here, and we just have got to compute all of these. We need to figure out what all of these are, which essentially this is the entire row of Pascal's triangle, right? Okay. So 6, choose 0. Let's start with that guy. Well, that's 6 factorial divided by, and then I do 0 factorial, the bottom one, and then 6 minus 0 factorial. Now I should mention here that 0 factorial is defined to be 1, okay? It just works out better that way when it's 1. If it was 0, this wouldn't make any sense. And so that's why we're going to say that 0 factorial, this is always just 1, okay? Okay, so we get 6 factorial divided by 6 minus 0 is 6 factorial. So this is just 1, right? 6 factorial divided by 6 factorial would be 1. Okay? Let's do 6, choose 1. Okay? We would have 6 factorial divided by 1 factorial, which is just 1, times 5 factorial, the difference between those two. Okay? Well, notice when you do this, you're going to have 6 times 5 times 4 times 3 times 2 times 1, right? All divided by 1 factorial is just 1, so that's not going to change anything. 5 times 4 times 3 times 2 times 1. That would be what 5 factorial is. Notice a bunch of this stuff cancels out, and we just get 6 here. Okay. Okay. So 6, choose 2. Let's do that. We get 6 factorial divided by 2 factorial times 4 factorial. So notice whenever we do this, the 4 is going to cancel out with the top, like 4, 3, 2, 1. Those will all cancel out. So what I'm left with is just 6 times 5, and then the 4, 3, 2, 1, those will cancel out with the 4 factorial divided by 2 factorial, which is 2 times 1. Okay, so we get 3 times, so 3 times 5 is 15. Okay. Let's give us some more space. Shall we? So 6, choose 3 is going to be, we do 6 factorial divided by 3 factorial times 3 factorial. So, because we do 3 factorial, because this is on the bottom, and then 6 minus 3 factorial. 6 minus 3 is 3. Okay. So notice this 3 factorial can cancel out with the 3 and the 2 and the 1 up here. So we just get 6 times 5 times 4. The 3's, everything below the 3 will cancel out with this one. And we're still left with a 3 factorial down there because there's 2 of them. Okay. And then we can maybe cancel some stuff out. The 3, we could cancel that out with that 6 to give me 2. Cancel out this 2 up there with that 4 to give me 2. So 2 times 2 is 4 times 5 is 20. Okay. And now, essentially, we're done because we made it halfway there. The other ones will just be, like, if you remember, Pascal's triangle was equal. It was kind of symmetrical on both sides, right? So at 6, choose 4, I'm actually going to get the same thing as 6, choose 2, right? In fact, when you plug it in, you get 6 factorial divided by 4 factorial times the difference, 4 factorial times 2 factorial, which if you notice here on 6 choose 2, we got 6 factorial divided by 2 factorial times 4 factorial. So those two are the same. It's just 15. Okay, kind of same thing for 6 choose 5. We just go back one now. This is going to be 6. And then 6 choose 6 will be the same as 6 choose 0 is 1. Okay. So now that I have all of the things in this row, I can plug those in and simplify everything. Okay. So my 6 choose 0 was 1. And we had 1 times 2 to the 6th. Let's actually figure out what 2 to the 6th is so that we can simplify this. 2 to the 6th power. That's 64. So this is 1 times 64. So just 64 plus 6 choose 1 we figured out was 6 here, right? Okay, so 6 times 2 to the 5th. (192) is 6 times 2 to the 5th, and then times a negative x. So we could maybe switch this to a minus 192x. Okay. Okay, now we look at our next term. So we got this one is taken care of, this one's taken care of. Now we're looking at this one, right? Okay, so I'm doing 6 choose 2, which we figured out was 15 here, right? 15 times 2 to the 4th, we'll throw that in the calculator. Is 240, and then we're timesing it by negative x squared. Well, negative x squared, when you square the negative, it just gets rid of that negative. So we're just going to have plus 240. That was what 15 times 2 to the 4th was. Times positive x squared now. Okay, so now we got that term. Done there. Now we move on to this term. 6 choose 3 we figured out was 20. Sorry. It was on the next row. We got 20 for that. So 20 times 2 cubed. Throw that in the calculator. Is 160. And then times negative x to the 3rd. So negative x to the 3rd. When you cube a negative, you'll still have a negative. So you'll have minus 160 x cubed. Okay. Okay, we're almost there, guys. Just a little bit longer. We can do this. Okay. Now we're on 6 choose 4, which we figured out was 15. 15 times 2 to the 4th is 240. Okay, and then when you do a negative to the 4th power, that's going to flip into a positive. So we're going to have plus 240 x to the 4th power. Okay. Okay. Then 6 choose 5 was 6. Okay. So we've got 6 times 2 is going to be 12. And then a negative to the 5th power will still be negative. So negative 12 x to the 5th. And then on this last one, 6 choose 6 is 1. A negative to the 6th power will be a positive. So x to the 6th. So this would be our answer here. Okay, now this is quite a tedious process, right? Um, but it's a lot easier than having to actually distribute out um, the thing we were dealing with, right, was 2 minus x all raised to the 6th power. If you distribute that out by hand, that would take a lot longer than doing this process. And so that's why we kind of like this. This makes a really hard problem into something that's actually kind of manageable. It's something that we can actually do in a fairly quick time, just by hand, which is pretty cool. So I really love this. I know that it's tedious to do by hand, and generally this is why, I mean, computers and calculators make this so much easier. But that's kind of the binomial theorem and why we care about it. So hopefully you've enjoyed this last lesson of 1050. We are going to have a test on chapter 8 next week. So you'll want to make sure you get caught up on this stuff, and we'll have some review before then. So I will see you then, and have a good rest of your day.